Greetings. Uh, Today we are going to discuss the first unit in brief, and then we are going to discuss about the MCQ related to first module. So we know very well that we are going to discuss about the computer network paper, and it is a regulation belong to 2013, and you will be having your exam in the MCQ pattern. And also they told that the MCQ pattern is for 1 hour. They are going to conduct for 60 questions, out of which 15 is for 1 mark, right? And that is the remaining thing is for 2 marks. So totally for 60 marks they are planning. That is two part. One is for 1 mark question, and another part is for 2 mark question. So in that way, they are going to they are planning to conduct this type of examination. So before going to discuss about MCQ question, we will discuss what are all the topics which are available under Unit 1. So it consists of networks, types of networks, what is protocol layering, and what is the meaning of TCP/IP protocol suite, and OSI model. And as far as physical layer is concerned, it deals with performance and transmission media. And also under the switching, we are going to discuss about two different types of switching. One is a circuit switching network, and another one is a packet switching network. So these are the topic which comes under Unit 1. So we will discuss briefly about this topic, and then we will discuss about the MCQ related to this unit. So we know very well what is the meaning of data communication. So exchanging a data between sender and receiver. So either whatever may be the devices between sender and receiver, it may be a different devices, but the effective communication between these two devices will happen based on these four fundamental characteristics. One is the delivery, the second one is accuracy, and third one is the timeliness, and fourth one is the jitter. So as far as delivery is concerned, so whatever the data which is forwarded by the source is delivered to the destination or not. As far as accuracy is concerned, right, whether the entire data forwarded by the source is handed over to the destination without any modification. That is very, very important. That is the meaning of accuracy. Timeliness, nothing but whenever a source is sending any data to the destination within the time limit. So there is a TTL, time to live. So that much of within the time limit whether the data is delivered to the destination. And jitter is nothing but it is classified into two categories. One is a delay and the jitter. So here it is both are correlated one. So delay is nothing but it is a constant delay. We know very well that for sending a one packet how much of time it's going to take, and the same delay is applicable for all packets. But jitter is totally different. For example, first packet the same size of the data is available in the packet, but the first packet taking 10 minutes and second packet is taking 30 minutes. For example, understanding purpose I am telling. That is the concept behind jitter. So these are the important characteristics associated with the data communication. And next one is the component which are associated with the network is, the first one is a message. So whatever the message I wanted to forward. The message may be either it may be a text or numbers or pictures or audio or video. Whatever may be the type of data. That is called as a message. And another important component is who is going to send the information. That is called as a sender. And receiver is nothing but who is going to receive the information. The best example for sender is will be having a system or any workstation or a telephone or video camera. These are called as a sender. Right? Capturing the information are called as a sender. And receiver is either the destination is also a computer workstation or you are calling to somebody else, right? Receiver is also a having a telephone, right? And a television and so on, right? So these are called as a message is the first component, sender, the second, third one is the receiver, and the fourth one is the transmission medium. The way in which you are sending a data from source to destination. So whether it is a connection oriented or wireless medium, right? So generally it is classified as into connection oriented and connectionless service. So if it is a connection oriented, then whether it is a twisted pair cable, coaxial cable, fiber optic cable, Or if it is a wireless medium, then what type of radio waves you are going to use for transmitting the data. And then the last one is a fifth important component is protocol. So protocol is nothing but the rules and regulations for making a data communication in a proper way. Or we can say that the agreement between two communicating devices. So without this protocol, two devices may not be connected and not able to communicate any information. For example, we need some interfaces, right? So if suppose I know one language, but the destination person, right, I am talking with them, that person do not know that language, then I need some intermediate person wanted to perform a translation. Like that, this protocol is helping the sender and receiver to communicate the information in a proper manner. So this is the second important aspects of this computer network, the component. That is message, that is nothing but data, sender, receiver, transmission medium and protocol. Then, so these are the way in which you are going to transfer the information. Sender is there, receiver is there. These are the two components, and message is the third component. So here sender should follow some rules and regulation, and at the same time receiver is also going to follow some rules and regulation. So here sender is also are associated with protocol, receiver is also associated with protocol. The message will consist of data, right? The data may be of any type. So these are the important component associated with network. And I already told the data may be represented in the form of text, numbers, images, audio or video. So this is the way in which the data or message will be transmitted to the destination. Then, so when you talk about data flow, so how the data is transferring between sender and receiver. So here will be the first method of communication is simplex, right? It is a one-way communication. So only one direction. That is, for example, this is the mainframe server. From server, the receiver, the client is going to receive the data. So always this server is providing the services. That is the reason why it is right. We are calling this as a one-way communication, right? So for example, in a street, only one way. That is, the opponent person will not be permitted to travel. Is it not? So like that, that type of communication is called as a simplex communication. Then second one is called as a half duplex communication. So what is the difference between simplex and half duplex is? Simplex is one direction, but half duplex is it will permit both direction, but at particular period of time, one direction communication alone can happen, right? So here you can see from this diagram, both way the data communication is possible. But when this station is sending any data to this station, then that particular station cannot be able to send the data to this station, right? Only one direction communication is possible at a particular period of time, right? So that is called as a half duplex. Full duplex is both sending and receiving is simultaneously possible. Then that is called as a full duplex communication. So data flow can be classified into simplex, half duplex and full duplex. Then the second topic is network. We know very well that what are all the right requirement as far as uh, making a data communication is concerned. In depth, we need more number of devices to be integrated for making a communication. For doing this communication, we need some interfacing devices, right? Such as routers or switches, right? And the modulators, right? Modem, right? Modulator, demodulator. So these are the devices or combined together, we can call it as a network, right? This network is purely based on three important criteria. One is called as a performance, second one is called as a reliability, and third one is right, very important one, security, right? So here the performance, right? For example, the data can be forwarded. Whether we can say that that network is a very good network. So the network is taking 1 hour time to deliver the data. Whether we can call that the network is a good network? No. The performance in the sense that it has to be delivered into the destination in a faster manner. Not only the fastness alone is coming under performance. There are so many parameters are there. So here the fastness is very very important as far as measuring the performance of the network. The second one is reliability. What is the meaning of reliability? I already told. Reliability is nothing but delivering the information without modifying the content of the information. Right? The whatever the information which is forwarded by the sender, that has to be delivered as it is to the receiver. That is called as a reliability. And third one is security. So here there are so many number of intruders are sitting on our network and they are capturing our data. So we know very well that we are sharing very important data. For example, bank related data. If they are, if the network is permitting those intruders to access our data, then they can do some modification. For example, I'm sending some person, I'm sending 10,000 rupees. If the intruder modify that information into 1 lakh, then what will happen? So I am compromising my security. So security is very, very important. So no intruder can access my data. Even if they access, they cannot able to understand what is the content present in my data. That is, these three are very, very important as far as network is concerned. Then, so whenever we are talking about the physical structure of the network, right? So it is classified into two categories. One is called point to point and another one is called as a multi-point. So I need not give detailed explanation about point to point, right? So there is a link which is connecting one station to another station. One to one connection is called as a point to point. And multi-point is nothing but multiple connections are possible. You can see this here from the mainframe server. There are multiple number of stations are sharing this link. If this station is performing a data transmission, these two stations will be kept silent. And when this station is performing a data transmission, these two stations will not perform data transmission. But all three stations are sharing this link. That is a concept again, point to point and multi-point. Point to point means only one destination. But in the case of multi-point, there are multiple number of destinations can share the common link to access their data. So these are the two important category of physical structure of connections. So whenever we are talking about the structure, then automatically it will come to our mind that the topology. That topology is nothing but the way in which our devices are arranged. That is called as a topology. So here when you talk about the topology, there are four different topologies can be classified under this network. One is a mesh topology, second one is a star, third one is a bus, and fourth one is a ring topology. We'll see what is the meaning of mesh topology. We'll come back again by seeing the diagram and then we can go for understanding. See here, there are 5 stations. So each station is connected with all other stations. For example, if you take this station is having a 4 connections, right? Station 1, this one, and also this one and this one, right? This is called fully connected. What is the meaning of fully connected? All stations is having a association or link with all other remaining stations. That is the reason why it is called as a fully connected mesh topology. So here every device has a dedicated point-to-point link. It is true. No? See here, this station is having a dedicated link to this station. So dedicated link to this station, and this station. So that is the reason why they told that it is a point-to-point link to other station. So here the term dedicated means that link carry traffic only between these two devices. We know very well what is the meaning of dedication. So here to find the number of physical connection in fully connected mesh topology, we should understand how many number of nodes are there and how many number of physical link. So n into n minus 1. So that many number of links are there. And here, however, each physical links allow communication in both directions. It is a duplex. So always we can divide the number of links by 2. So here sending and receiving is possible. So the total number as far as mesh topology is concerned, how many links are there? It may be asked in 2 mark question. So how many number of links are there? N into n minus 1 divided by 2. That many links we want. So here as far as this diagram is concerned, how many stations are there? 5. 5 into 5 minus 1, 4. That is 5 into 4 by 2. That is 20 by 2. That is 10 links are that because one link is shared by both sending and receiving. Right? And what is the demerit? Whenever we are having multiple number of topologies, then automatically each and every topology will be having its own demerits. So here, as far as mesh topology is concerned, we need more amount of cable, and installation is very difficult, and more it will occupy more space. These three are the demerits of the mesh topology. The second one is star topology. So here it is most of the network is following this topology. We'll see the diagram and then we will come back here. So this is the architecture of star topology. So here there are n number of stations are there. All the stations are connected with hub, right? So through hub only the accessing can be done. For example, this station wanted to communicate to this station means it can communicate to hub. Through hub only we can communicate to this station, right? So here the controller, which one is called as a controller? The hub is called as a controller, because without the knowledge of hub we cannot able to make a data transmission. So in this way star topology is functioning. So what is the advantage of having this one? Less cabling need to be housed. Is it not? So robustness. One link fails, then that alone will be affected. So this is the advantage of having star topology. What is the demerits of this star topology? So if suppose hub fails, the entire system fails. So here the star topology is having a connection oriented, so it can be used only in local area network. We'll discuss later on what is the difference between LAN and WAN. So the demerit is if hub goes down, then total entire network is collapsed. The second one is can be used only in local area network. So these are the disadvantages of advantage and disadvantage of star topology. The next topology is called as a bus topology. So here all the stations are sharing the same common link. If this station is wanted to make a communication, then other two station will be closed. And if this station wanted to make a communication, these two stations will be closed. Here there is no direct controller or any controller hub or that. So only the station itself has to make a communication between themselves. So what is the advantage of this one? So it is a multi-point. Why we are saying this multi-point? So we don't have any controller or coordinator. So any station can communicate with any other station. So one long cable acts as a backbone. So that's why I told the entire link is shared by all other stations. So there is a drop line in connection running between the devices. So here you can see that, here you can see that there is a drop line. So if the drop line is open, then this station can communicate. If this drop line is open, then this station is communicate. So like that, by using a drop line, the communication will take place. So what is the advantage of this bus topology? It is easy for installation. When you talk about demerits, so it is because all are sharing, no reconnection and isolation is very difficult, and there is a probability that having more probability that signal reflection will be there, which will degrade the quality. Is it not? Because if all other stations are simultaneously performing a data transmission, obviously degradation of the signal will take place, and a fault or break in the bus cable stops all transmission. So this is the biggest disadvantage of bus topology. So it also reflects signal back in the direction of origin, creating noise. So reverse direction is also possible. Signal transmitting to the reverse direction is also possible. And last one is a ring topology. So here you can see that there is a token that will be circulated among the ring. And if suppose this station wanted to perform a data transmission, it will get the token and it will perform the data transmission. So it will be in the forward direction only. So if you want to apply a reverse direction, that is also possible, but we wanted to spend extra amount. For example, for this station wanted to communicate to this station, always the token will circulate in a clockwise direction. So here that information, the data has to reach here, reach here, reach here, reach here, and then only it will reach. It is taking more time. Instead of that, if both direction is there, then immediately it can backwardly it can send the information to this station. That is the advantage of backward link. But usually installation will be there in forward direction. If you want to backward direction also, then you want to spend more cost. So in a ring topology, each device has a dedicated point-to-point connection with only two devices on either side. So signal passed along in one direction. Right, each device in the ring incorporate a repeater. So when a device receive a signal for another device, it regenerate the bit and pass them. Why this repeater is needed is, so for example, I wanted to send information here. So it will go in clockwise direction. When it send here, then the signal will be regenerated so that without any error it can be delivered to this. Here also regenerated. Like that, each and every, like we are having a booster. So which will increase the clarity of our system, like that. When you are talking about demerit, it is a unidirectional traffic, but I told specialized device only having a both direction. That is the first drawback. In simple a ring, a break in the ring can disable entire network. This is also we know, right? If there is a third station is in downstate, then entire communication will be stopped. The weakness can be solved by using dual ring. I already told. So that is the reason why if you want to, the weakness, I told it is taking too much of time means then we can have a dual ring. So this is also another arrangement. So we have seen the topology. This is very important topic. So mesh topology, right? What is the first topology? Mesh topology. Second one is a star topology. Third one is a bus, and fourth one is the ring topology. So this is the second topic of first module. Now we will see the third, that is the network types. So generally this network types is classified into three categories: local area network, wide area network, and metropolitan area network. So local area network is privately owned network is called as a local area network. We know very well. So it can be generated or created for home office and for limited space. The coverage space is very limited. So you can see this. So the all the systems are available in the entire, right, in one building, and we are interconnecting those devices together, right? So this is called as a local area network. And second one is metropolitan area network. So here it is much larger than LAN, right? But it is not large than wide area network. It is in between. MAN is in between LAN and WAN. So here you can see that, for example, we are having a satellite campus. So Arts College, our college, and NIET, sorry, NIT. So if you are combining a network, if these three colleges are nearby and we are interconnected with metropolitan area network, and all the data will be stored in centralized system. So like that we can create school campus, and multiple number of buildings can be connected together by using a MAN. Little bit advanced level of LAN. And third one is a wide area network. We know very well that by using a wide area network only, we are connecting so many number of networks together. Is it not? So here you can see this. This is the wide area network. So here it is a switched WAN, right? You can see this, so many number of networks are there. So there are different, it may be in India, this system may be in US, and this system may be in Germany. So all are interconnected using this switched WAN. That is the coverage area of wide area network is very high. So that is the concept behind wide area network. The connectivity is very lengthy. And here there is a differences between LAN and WAN. So you just go through this, right? It is for covering only local area and it is for wide area network. So here it is called as a private, but it is public. And speed of LAN is high because it is covering only less area, but WAN is slow. Propagation delay is short. Delivery delay is short, but here it is long because we are transferring a data from India to US. It is taking more time compared to transferring from one system to another system. Both are available in the same network, and there is less congestion, but here more congestion is there. Fault tolerance is high. Here fault tolerance is less because we cannot able to identify the fault as easy in the case of WAN. So these are some basic differences between LAN and WAN. Then here internetwork. What is the meaning of internetwork? Connecting two offices together. This is one network. This is another network. By using an external router, we are connecting these two by using a wide area network. So that is the reason why it is called internetwork. Connection between two local area networks together by means of wide area network is called as the internetwork. And the next one is protocol layering. I already told what is the meaning of protocol. Protocol is nothing but the set of rules, right? So here, when you talk about protocol, the syntax, semantics, and timing, these three are the important key elements for protocol. So what is the meaning of syntax? It is nothing but the structure or format of data what we are going to use. That is called as a syntax, right? The first 8 bit of data is address of the sender, right? The information about the data is called as a syntax. Semantic means it refers the meaning of each section bit, for what purpose we are using that bit. For example, the address specified the route to be taken or final destination of the message, or that is a particular node is a destination node or it is an intermediate node, how it can be identified. That is called semantic, the meaning of the information. Then third one is time. So the timing is nothing but it refers to characteristics. One is when data should be sent and how fast they can be sent. Right? That is very, very important. What is the meaning of when data should be sent? The destination mission is ready, then only you can able to send the data. That is the first thing. Then how fast this information has to be sent, right? So because the destination mission, we wanted to understand the capability of the destination mission, then only we can send the data. So for example, the sender produces data at 100 Mbps and receiver produces data at only 1 Mbps, right? Whether it is possible to send 100 Mbps at a time, it's not possible because the receiver can able to receive only 1 Mbps, right? 100 times we wanted to send. So that is the meaning of understanding the capability of the destination. So we need to understand when the data should be sent and how fast it should be sent to the receiver without compromising the data. So what is the meaning of standard? So there are different operating environments are there. What is the meaning of operating environment? That is a software, hardware, as well as the operating system combined together is called as a operating environment. I am going to send a data from by using one operating system, and I cannot expect the destination machine should also use the same operating system. So it may be a different operating system. How it can be compatible to both, right? So for that, the rules and regulation has to be formed. So these are the standard rules and regulation that has to be followed to maintain the communication between sender and receiver. That is the meaning of standard, right? So here we need to create and maintain an open and competitive market for equipment manufacturing. So to guarantee national and international interoperability, quality, how much of quality you are going to provide, right? So we are saying that it is a standard product. What is the meaning of that? That the quality of the product is very high. It is accepted one, right? So that type of product we are calling is as a standard. They will be following certain rules and regulation without compromising the quality. Then we can say that it is a standard product. So like that, here also in network also for data communication also we need to follow some standards. So yeah, generally this data communication standards are divided into two categories. One is called de facto and then another one is called as a de jure. So what is the meaning of de facto? Right? Standard that have not been approved by organized body. That is called de facto. So the fact may be correct, but it is not a standardized one. Nobody is approved. Then it is called as a de facto. De jure is nothing but those that have been registered by an officially recognized body. So they declared this product or this communication medium is a standard one, de jure one. Then it means that it is following the rules and regulations, standards of the rules and regulation, right? And this is the example for right basic requirement of protocol layer. So let us assume that Maria wanted to communicate with Anne. So there are three layers that are very, very important. So here when Maria wanted to talk with Anne, so she will be in a talking mode and Anne will be in a listening mode, we know. Then, so whatever the information she wanted to forward, that will be encrypted, right? Making encryption is nothing but, right, plain text will be converted into ciphertext. Then it will be forwarded to the mail. and it will be received by the receiver side, layer 1. So once it is received, it will be in the form of encrypted one, ciphertext. So the ciphertext has to be decrypted by using a right by using a decryption algorithm. It has to be converted as a plain text. So why we need to do this? It will be unreadable form, right? By applying a decryption algorithm, it has to be converted into readable form, that is a plain text form. Then right, it will be submitted to Anne, so that Anne can understand, listen what is the content which is forwarded by Maria. So this is a simple concept of understanding the protocol layer. Now why we need this? The next topic is we are going to discuss in detail about the TCP/IP protocol suite. Then, so here what is a TCP/IP protocol suite? So it is a set of protocol organized in different layers, hierarchical layers. So here it is also called TCP/IP protocol suite is also called as a 5-layer model. You can ask, ma'am, always you are saying that OSI model is consist of 7 layers. Yes, OSI layer is having a 7 layer. Before that TCP/IP protocol suite is introduced, that have only 5 layers. So we are going to discuss those layers now. So here you can see that you are having an application layer, transport layer, internet layer. Internet layer is nothing but a network layer, and network interface is nothing but a data link layer and hardware devices. So application layer, through application layer, the end user will submit the request, and by using a transport layer, the data transmission will take place. By using a network layer, we are going to convert our data into packets, and by using a network interface, that is nothing but a data link layer, which will divide our packets into number of frames, right, to get a data in a error free format. And hardware layer is called as a physical layer, right, it will receive the data and in the means of zeros and ones. So these are called as a layered architecture of TCP/IP, or it is also called 5-layer architecture. So we have discussed in detail in the class. So I won't take much of time. You just remember 5-layer, and as far as TCP/IP protocol is concerned, right? And now we are going to discuss about 7-layer. So the expanded version of TCP/IP is the OSI model. So we know very well that OSI is nothing but open system interconnection, and this system, open system interconnection architecture, is accepted by the International Organization for Standardization. Why we need this ISO? So here I told we are using a different operating environment. We are making a communication between different operating environment. Somebody has to accept the rules and regulations. That is called as an International Organization for Standardization. So now we will see the architecture. Right, these are the 7-layer. Always please remember, even in interview they are asking you to tell about OSI layer. Always you start from bottom to top approach. So you should always tell physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So you should not you should forget network layer. Before that you should not tell transport. The sequence should be same, right? So it is very important, don't change the sequence, or don't tell in top down approach. It should be always a bottom up approach. Now we will see the responsibility of each and every layer, because I already told everything in the class. So we know very well that in physical layer will be the mechanical and electrical devices are available in the physical layer: cable, plug, pin, and a modulator, signal strength identifier, voltage level monitoring, bit transmission, conversion of bit signal, analog to digital, right? So these are the responsibility of the physical layer. So we know very well that, so we'll be receiving a bits from the data link layer, always from top to bottom. So it will be zeros and ones. Physical layer receive the data in zeros and one as a digital form, and it will convert to analog, and it will be received by the receiver. Is it not? So that always please remember, physical layer can able to understand only zeros and ones. Right? The main responsibility of physical layer, so it provides interfaces between the sender and receiver, and always it should be representation of bits, and it is very important how much speed the data, the bits are transmitted. That is called the data rate, and synchronization of bits. Because when a sender is sending any data, receiver should be in a listening state. So we should give some time for the receiver to synchronize with the sender. So adjusting the speed between sender and receiver. For that we need a synchronization bits. These are the major responsibility of physical layer. Then next one is a data link layer. So here you can say it is a hop to hop, node to node. The data transmission will be responsible between node to node. Right here the important duty is framing. So dividing, grouping the bits, right, that is called as a framing. A frame consists of group of bits, that is called as a frame. And here the physical addressing. So from where it is the data, the bits are originating, it has to identify. Right, the frames are distributed to different system on the network. Data link layer adds header. Header is nothing but the address. Right, so the frame along with address, it has to be delivered in the medium. Then only from the address only, right, by identifying the address, it will be delivered. All the frames will be delivered to the destination. So that is called as a physical framing and physical address. Then flow control, adjusting the speed between sender and receiver is called as a flow control. And error control, whatever the data is sent by the sender has to be received at the receiver side without any modification. That has to be checked. Right, checking as well as correcting is also possible. That is a add-on feature. Correcting is a add-on feature. Right, these are the responsibility. And another important responsibility of data link layer is access control. If two or more devices are connected in a single link, then it has to give access to any one of the device at particular period of time. That is called access control. So these are the responsibility of data link layer. Then very important layer in OSI model is network layer. So here in this network layer, so everything will be considered as a packets. The data transmission will be taking place in the form of packets. Who is delivering the information? The transport layer delivers the information to the network layer in the form of packets. Right? So here the main functionality of network layer is logical address. What is the meaning of logical addressing? The IP address, identifying the IP address. That is called as a logical address. And another important thing is routing. So by using which route it has to be delivered. So the shortest route has to be identified between source and destination, and it has to be delivered. So routing has to be taken care by this network layer. Right? This is the architecture of network layer. So it is a hop to hop delivery. Hop to hop means, so if source is here, destination is here. So there are so many interfacing devices. So for forwarding one packet from this A to B, this is one hop. And B to C, another hop. C to D, another hop. So it is a hop to hop communication. Right? And the next layer is transport layer. So the transport layer is responsible for process to process delivery. Right? You can create a single connection can have multiple number of processes. I already told you are creating a multiple window in a you are accessing a internet. Right? How the machine is delivering, the server is after doing authentication is delivering the information to the same window by using this process, right? Process ID. Like, so transport layer is responsible for process to process communication. So here service point addressing, exactly identifying the the exact window by using a process ID, that is called the service point addressing or port ID. Segmentation and reassembly. What is the meaning of segmentation and reassembly? I wanted to send 1000 bytes of information, but my destination machine can able to receive 100 bytes. So I wanted to divide this 1000 bytes into 10 different fragments. That is called segments. Then I will be transferring to the destination. So all 10 segments has to be assembled together, and then only it has to be handed over to the destination. That is called segmentation and reassembly. Right? It is also called as a fragmentation. Segmentation and fragmentation both are same. Then here the responsibility of the transport layer is connection control. So either it can use a connection oriented protocol or connectionless protocol. Right? I told the transmission medium. If a connection oriented, then the cable will be there between sender and receiver. Connectionless, there is no communication link or wire between sender and receiver. And it is also performing a flow control. That is nothing but adjusting the speed between sender and receiver, and it is also responsible for identifying a error. That is, error control mechanism is also there, right? And the another important layer is called as a session layer. It is also called as a dialogue control. What is the meaning of dialogue controller? Whenever any machine wanted to establish a communication with another machine, the session layer is placing very important role. What is once a session is established, it is not necessary you wanted to perform a continuous communication. Right? You can create multiple conversation under session. For example, I am requesting a destination mission. I want to talk to you 10 minutes. Okay, that session is given. So once given, first 2 minutes I am talking and somebody else is coming and talking to me. At the time I am stopping this. After 2 minutes I am talking. So within 10 minutes I can do multiple number of conversation. Until then, until I close the session, right? This many number of conversation I can make between sender and receiver. That is the important aspects of session layer. That is the reason why it is called as a dialogue. The entire conversation between sender and receiver is controlled by this session layer. So once session is closed, then how I can talk with the other person? It's not possible. Is it not? So that is the reason why it is called as a dialogue controller. So dialogue control I told. Synchronization, it is very important. Right? How? Because for example, I want to send 1000 pages. Already I have forwarded 500 page. Right? During 501 page I am sending, there is a problem, right? So if suppose I'm not having the synchronization mechanism, again I wanted to start from first. Since already synchronization mechanism is there, so it will accept 500 packets or 500 pages first, and it will ask us to start from 501 onwards. So that is the meaning of synchronization, right? So that is provided by this session layer. Then the next one is a presentation layer. So from the name itself, you can understand how that information has to be presented to the destination. The syntax, right? The format and the methodology which we are going to deliver the information to the destination. For example, you are having a Word document. You wanted to convert into PDF, right? You are using an interface. Like that, this presentation layer will receive the data from the sender and in convert according to the destination person requirement and deliver the information. That is the concept behind the presentation layer. The translation, right? The process in two systems usually exchange information in the form of character, string, numbers, and so on. So the translation, conversion according to the destination person. That is the first responsibility. Then encryption. Why? For making a security purpose, we are encrypting the data and destination we are decrypting. And another important thing is compression. Why? So if the data is very large, right, audio, video files we are sending, then obviously we need to compress the data and then only it will be transmitted to the destination. Otherwise, it is not possible for us to transfer the very large data. It will take more time. So for that purpose, we are doing a compression. So these are the responsibility of the presentation layer. Obviously, the last layer is called as application layer, where the human being is interfacing with this application layer. Whatever the user requirement has to be provided by this application layer. For example, I am giving my username and password for accessing my mail. Is it not? So who is the person who is accessing? The user or human being. That is the reason why I told the application layer is always interacted with the user. In machine also possible. So most of the time, right, the user is going to interact. Right, there are different types of application layer. Email is there, remote file access, shared databases, distributed information. All are coming under application layer services. Right. And this is the summary about OSI layer, the responsibility. You can see right before exam, you just see this one so that you can understand what is the responsibility of each and every layer. Then performance, I already told performance will have so many parameters. One of the parameters is speed. The first parameter is bandwidth, right? The size of the data which you are going to send, the capacity of the link, right? You are connecting a link. For example, you are connecting a water pipe, right? If the pipe, diameter is lengthy, then more water will come. The pipe diameter is less, then less water will come. That is called bandwidth, right? The capacity of the link. If the capacity is high, more data can be transmitted. If the capacity is low, only less data alone can be transmitted. That is called as a bandwidth. Then second one is throughput. How much of output I am getting. So if I study more, then I will be getting good marks. The outcome is called as a throughput, right? So how much of information you are going to receive. I am sending 100 bytes of information. Only 97 bytes of information is coming within the time limit. Then my throughput is only 97%. Right? Output is nothing but throughput. Right? And example they have given. You just go through the example. And the next one is a latency, right? The latency includes so many number of delays, right? So propagation time, transmission time, queuing time, and processing time. What is the meaning of propagation time? So propagation time measures the time required for a bit to travel from source to destination. That is called as a propagation time. The example you can see later on. Propagation time. Transmission time is how much of time is taking to forward this one bit from sender to receiver. That is called as a transit time or transmission time. So it is purely based on the bandwidth as well as the size of the data. And the third one is queuing time. So here there is a intermediate device which is receiving a data and forwarding. So what it will do, there is a buffer is available. In that buffer all your data will be stored and one by one it is going to process. Right? Waiting time. Before processing, waiting time is called as a queuing time. Then last one is I told jitter. It is also a delay but it vary, right, according to the situation. Right? So for a same server you are accessing. For first person if accessing, the information will be delivered within a second. Right? If more number of connections are there, the same person is accessing the same information but he is getting information after 5 minutes. That is called the jitter. Same source and destination, but the time is different because of there may be a problem, multiple number of connections, right? There may be a problem, but the delay is nothing but the same distance a bit is traveling but taking different time to reach at the destination. So that is called as a jitter. So these are the parameters responsible for measuring a performance of the network. And next one is I told transmission medium. So either it may be a connection oriented or connectionless, right? So these two are the major category under transmission medium. So when you talk about a connection oriented service, right? So there are so many guided media and guided media. Generally connection oriented, connectionless is called as a guided media and guided media, or it is also called as a wired or wireless. So under wired one, twisted pair cable is there, coaxial is there, fiber optic is there. Under unguided wireless, radio wave, microwave, infrared, these are the classification of these things, right? So you just go through all these type of right cable because right under this twisted pair, again there is a two different classification. One is called unshielded twisted pair, and that is the second one is called as a shielded twisted pair. So the coverage metal shield is there, extra provision, so that the leakage will be avoided. The interference will be minimized because of this shielded twisted pair. That is the basic difference between UTP and STP. And this is a coaxial cable. So you will be having an inner conductor and after that insulator is there and outer conductor is there. It is a shielded one. So why we are having these many number of shield in the inner conductor to protect the inner conductor is to avoid leakages, right? Not only avoid leakaging, it will reduce the interference also. The data transmission will take place without any compromising the data. Then here the whenever you are talking about wired communication, the fiber optic is very best. Why? Not only it is having more secure, but also it is very fast. Right? You can see that the cladding is very important as far as this fiber optic is concerned, and it protect our data not only the shield, right, it is acting as a shield of our fiber optic cable, but also it won't allow the data to deviate, right? So always it will be in a reflection, right? So that it will be equal reflection is there, so that the information will be having more clarity, right? The cladding will be, right, glass or plastic, but glass cladding is better than plastic cladding. And propagation mode. So here when you talk about propagation mode, again it is classified into two categories. One is called single mode and multi mode. And as far as multi mode is concerned, again it is classified into step and graded index. So all this explanation is given right here. We just go through this. So this is as far as this example is concerned, they have given us a plastic buffer is also given, out, glass cladding is there, outer coverage is there. So this much of production is there, so that the deviation is very less. So what is the advantage of fiber optic? So here higher bandwidth and less signal attenuation. Attenuation is nothing but interference, less interference. So immunity to electromagnetic interference, because the glass cladding is there, so it won't it will protect our data, so it will have a immunity to electromagnetic interference. And here it is a resistant to corrosive materials, right? It won't affect any other magnet and all that, then it won't affect any way in fiber optic. And lightweight and greater immunity to tapping. And main disadvantage is installation and maintenance, and cost is very high. Unidirectional light propagation, so only one direction only we can use, reverse is not possible. And the last topic is transmission media. So I already told unguided media, right? Wireless media. So electromagnetic wireless communication. There are here. This is unguided media is right. We can do it in several ways, but generally it is classified into three categories. One is a ground propagation, sky propagation, and line of sight propagation. So these three are the three different categories available under unguided media. So here, as far as this ground propagation is concerned, so it will coverage area is less than 2 megahertz, right? And here you can see that the coverage area ground. So the tower will be covering based on ground coverage area will be calculated. And second one is a sky propagation, that is 2 to 30 megahertz. You can see that the coverage area is in a sky. So that is the reason why it is called sky propagation. And third one is line of sight propagation, satellite. Through satellite we are accessing line of sight, LOS, right? Communication. So it will be above 30 megahertz, right? This is very high, right? And clarity also. So in here generally these radio waves are classified again into right two category. Microwaves are categorized into two category. One is a parabolic dish antenna and horn antenna. See the difference between horn and parabolic. So the focus area will be more as far as parabolic, but as far as horn is concerned, only the funnel like thing, only restricted area coverage, right? So it depends on situation only we can go for a parabolic dish antenna or on antenna. And last one is the infrared. You know very well that what is the meaning of infrared communication. So here it has to right 300 gigahertz to 400 terahertz, right? That is the right strength of infrared. So infrared signals can be used for short range communication in a closed area. Like we'll be having the direct line of sight, like our remote, TV remote, right? There is a direct communication between our remote and TV. Is it not? It should cover a short area. The coverage area will be very less, right? And last one is a switching. The switching is classified into two categories. One is called as a circuit switching and another one is called as a packet switching network. We'll see the difference between these two. So as far as circuit switching is concerned, so here you can see that four lines are connected in a switch. Right, at particular period of time, any one of the line can communicate. But if this line is established, then other three has to be put into idle state. Right, only one communication at particular period of time is possible. Right. And in the case of packet switching network, right, you can see that so all can communicate. There is a router and all the data will be queued. A special queue is there. So it is purely based on first come first serve. So in the queue, for example, this packet may be related to the third system. The second packet may be related to first system. So it came 10-10, it came 10-20. Then based on that only it will be stored in the queue. And one by one it can be processed. And here all four system can communicate at the same time because it will be stored in queue, and queue from the queue only the router going to take and process the information. That is the advantage of having packet switching mechanism. So there is a difference between this circuit switching and packet switching. You can go through this later on. So with that I will conclude just brushing up the first module. Now we will see the related MCQ questions of first module. See that the IETF Internet Engineering Task Force standard documents are called RFC. Right? RFC is nothing but request for comment. RFC. So whenever I wanted to know about the protocol RFC, right, 281 or any number, right, the associated number if I give, then it will give you description about that particular protocol. Request for comment. IETF standard documents are called, right, where this IETF is a standard, right, that associated documents are available in RFC, request for comment, right. The structure or format of data is called, I already told, it is a syntax. And the communication between a computer and keyboard involves dash transmission. Computer and keyboard. The communication between keyboard to computer. It is a simplex. Right? Only one direction. Simplex communication. The first network was called ARPANET. Advanced Research Project Agency Network, ARPANET. A dash is the physical path over which message travels. The medium. A medium is the physical path over which a message is travels. And a dash set of rules that govern data communication. A protocol set of rules. Is it not? I already told protocol is nothing but set of rules. And there are three or more devices share a link in dash connection, multi-point connection. A dash is a device that forward packet between network by processing the routing information including in the packet. So who is going to identify the route? A router is a device that forward packet between network by processing the routing information included in the packet. The physical layer is concerned with bit by bit transmission. Which transmission medium provide highest transmission speed in a network? Which transmission medium? Optical fiber. Fiber optic cable only providing highest transmission rate. Bits can be sent over a guided and unguided media as analog signal by digital modulation. I told analog to digital, digital to analog. Both are possible. Is it not? Analog to digital modulation. The physical layer is responsible for line coding, channel coding, modulation. All of the above. Right? All three responsibility will be associated with physical layer. The physical layer translates logical communication requests from the dash into hardware specific operation. The physical layer translates to communication from where it is going to get, from the data link layer. Right? A single channel is shared by multiple signals, that is called multiplex. Right? Wireless transmission of signals can be done via, right, radio wave, microwave, unguided media. All are, right, wireless transmission. So all of them mentioned there. When collection of various computers sends a single coherent system to its client, then it is called as a distributed system. Why I am saying it is a distributed system? As a client, I do not know which server is providing the information. Right? I am thinking that I will be getting a information from a local server, but that information is provided by some other server. That is the reason why I am having an illusion that I am accessing from a direct server. So that is the reason why it is called as a distributed system. In a computer network, nodes are dash. Originate the data, route the data, terminate the data, because sending, receiving, as well as the router or interfaces also routing the data. all the mentioned. Nodes are responsible for all the three operations, sending, receiving as well as routing. So communication channel shared by all machines on the network is a broadcast. Is it not? Everybody who and all tuning to the particular frequency, everybody will be getting information. That is called broadcast. Bluetooth is an example of personal area network. Wireless transmission of signals can be done radio waves, microwaves, infrared. Already we have discussed all the mentioned. The data link layer takes packet from dash and encapsulates them into frames for transmission. From which layer it is getting data link layer? From the network layer. Which of the following task is not done by data link layer? Framing is there, error control is there, flow control is there, but it won't do channel coding. Channel, who is doing this channel coding? It is a physical layer responsibility. CRC stands for cyclic redundancy check. It is for error correction mechanism. So which of the following is a data link protocol? Right, Ethernet is a data link, point to point is a data link, HDLC is also a data link layer. All the mentioned layers are associated with data link. The network layer is concerned with the dash of data, packets, I already told. Which one of the following is not a function of network layer? So routing is responsible, internetworking is responsible, congestion control is responsible, error control is responsible for data link layer and physical layer. And a 4-byte address consists of what? Network address as well as the host address. That is a 32-bit address. 4 byte means 4 into 8, 32-bit. It have network as well as the host address. So the network layer protocol for internet is internet protocol, IP. Is it not? So these are Ethernet is data link, hyper is hyper transfer protocol, and file transfer protocol is which layer? Application layer protocol. ICMP is used for what purpose? Error and diagnostic function. What is the expansion of ICMP? Internet Control Message Protocol. So transport layer aggregate data from different applications into single stream before passing into transport layer handovering data to which layer? Below layer, network layer. Which of the following are the transport layer protocol used in networking? TCP and UDP. Physical or logical arrangement of network is called as a topology. The arrangement of network is called as a topology. Which network topology requires a central controller or hub? Star topology. Dash topology require multi-point connection. Bus. So data communication system spans states, country or whole world. Is a no, it is a wide, not a man. Sorry, it is a WAN, wide area network. Because states, country or whole world is wide area network, not metropolitan area network. Sorry. Right? Data communication system within a building or campus is called local area network. WAN stands for wide area network. Which of the following delay is faced by packet in traveling from one end system to another? Right? All of propagation delay is there, queuing delay is there, transmission delay is there. For example, for 10 Mbps Ethernet link, if the length of the packet is 32-bit, the transmission delay is dash in microsecond. Right? 3.2. Right, and the time required to examine packet header and determine where to direct the packet is part of, right, the time delay is coming under processing delay. Propagation delay depends on distance between the router. Generally it is a distance, not only router, distance between any system. How many layers are present in internet protocol stack? So TCP IP is also called as an internet protocol stack, right? TCP IP layer have how many layers? 5 layers. The number of layers in ISO OSI model is 7. The functionality of the presentation layer is data encryption, data decryption as well as data compression. So these are the some important questions associated with the first module, and please go through the presentation related to first module as well as the questions, because we cannot expect the same questions, right? It will be associated with this one, so that please understand and use it. All the best. Subsequently, I will put a video for remaining modules also. Thank you.